So let's think this through. What I've done is I've sketched the distribution of IQ scores here. And what we spend a lot of time doing, because it sets the stage for bigger, better stuff later, is we want to look at proportions and percentages of scores in normal distributions. So that's going to play a big role. So I'm going to write that down. So proportions and percentages in normal distributions. Now, I don't know if you guys know this or not, but there's something kind of special about having an IQ of 130 or higher. It turns out if you've got a documented IQ, from a certified IQ test giver, it's actually what my wife does. And if you have an IQ test score of 130 or higher, then you can send your application in to a place called Mensa, and they'll send you an application to be part of their little geeky group. So what I would like to know, keeping in mind, or not what I would like to know, what I would like to explore, because I already know this, what percentage of people has IQ above 130? And we'll find out later. They're asking what proportion or what percentage. Those two questions are equivalent. So guys, in answering that, if we can find the area under the curve that is shaded to the right of 130, it turns out that that will answer our question for us. Now, what we know so far, again from the last video, is we know that 68% of our data is from one standard deviation below to one above. And we know that 95% of our distribution is from 2 standard deviations below to 2 standard deviations above. Using this information only, we can see that we're missing 5% of our distribution. So this area right here, we'll call that A1. And this area right here, which we'll call A2, A1 plus A2 has to equal 5%, because the area under the curve must be equal to 100%. And it brings up a good point. Something I really want you to kind of tattoo to your brain is that when we do a histogram for a population, we would want to use 100% of our data. Well, if you think about a normal distribution, at the end of the day, a normal distribution sits on top of a histogram no longer approximately bell-shaped and symmetric, but perfectly bell-shaped and symmetric. It sits on top. So what we look at in a normal distribution is we remove the bars of the histogram and only look at the smoothed out distribution, smoothed out curve. In this case, the normal model. So guys, it should be clear that A1 plus A2 has to add up to 5%. And since we want half, only this upper tail part that I've shaded in, then we would know that 2.5% approximately of people has IQ greater than 130 or are a genius. Trust me, you'll hang out with a lot of people that'll make you think they've got IQs of. I had one guy one night at the golf course tell me his IQ is 185, and the probability of that is just a little small, and he did not. But anyway, guys, if you have a certified IQ test score of 130 or higher, then you are officially classified a genius. And I'm not talking about one of those goofy things you take on Facebook or Twitter, or one of those questions. Sometimes there's these IQ tests that you could take like 10 questions, and they'll tell you your IQ. No, they don't. They tell you an IQ, but you've got a better chance of flipping a coin than you do taking one of those things. All right, gang. What I want to do now is I want to jump to the TI-84, and I want to show you some pretty interesting features. So what I'm going to show you here is how to find proportions. I'm going to abbreviate here because I don't write real well. Proportions and percentages using your TI-84. Alright, so let's get a little bit of information before we get there. When we have a normal distribution like this, if we take a point A and another point B, and we want to find the percentage proportion of the scores between those 2 points, what we use is we use a key called the normal CDF key. And the normal CDF key has very strict guidelines on what you enter in the after the parentheses. Guys, in the first entry you'll put your left bound. In the second entry you'll put your right bound, the mean, and then the standard deviation. So for example, if we wanted to find the percentage of IQs, my dog is going insane out there, between, for example, 92 and 117, I don't know why in the world anybody would want to know the percentage of scores between a 92 and 117, but let's pretend they do. Then what we would do here is, again, sketching out the normal distribution with 100 in the center. So a 92 would be about right here, and a 117 would be about right there. So guys, the area between the curve, between the 2 points, would give us the percentage between 92 and 117. To find that, we would use the normal CDF. And I'm going to show you how to find that in just a second. 92, 117. The mean of IQs is 100. And the standard deviation is equal to 15. Now, things change a little bit. What if we want the proportion of IQs, keeping in mind that IQ proportion and percentage, basically same stuff, just a matter of the way we report our final answer. So what if we want a proportion of IQs below 122? Well, guys, sketching out our distribution, 122 would fall to the right of the mean, and everything to the left of 122, all the way down to minus infinity, would give us the proportion of IQs below 122. Now this is one place where you've got to kind of throw common sense out the window and trust the people who have modeled IQs with the normal distribution to have taken care of the phenomena of finding a proportion of IQs below 0. It makes no sense that we could have negative IQs. But when we do the calculation, we trust the modeling of the distribution, let me say that again, of the distribution to include that. So what we would do here is we would do normal CDF. Guys, what we do for negative infinity is what we call negative E99. I'll show that in just a second. Go to 122, 100, 15. I tell you what, hold on just a second. Let me let my dog in before she has a coronary. Alright, sorry about that, but my dog would really care less about normal distributions. My dog just wanted in. So, guys, on the reporting, I said, really that percentages and proportions are the same except for the reporting. Guys, the way I want you to get in a habit of reporting percentages is report percentages always in statistics to the nearest tenth of a percent. I want you to get into a habit of reporting proportions to 4 places beyond the decimal. And I'll illustrate this in just a second. All right, gang, let's get out of this, and let me go into my applications and get. Let's see, where's the calculator? There it is. It's actually going to be a pretty short video, which. Let's see, continue with the trial version. All right, so what we have here is a scatter plot of residuals over the independent variable. So what I want to do is let's go back to the problem. And I forget what it was, but the percentage of IQs between 92 and 117. So again, the percentage of IQs between 92 and 117. So what I would do to get to the normal CDF key, I go second function. I come over to VARS and come down to number 2. So number 2 is the normal CDF key, and guys, you'll hear me say a lot, or you'll hear me call the normal CDF key the P key. And it turns out when we need proportions, probabilities, percentile rankings, and percentages, pretty much anything that starts with a P in this class that deals with normal distributions, we go to this key. So guys, we hit enter. And again, we want to look at the percentage of scores between 92. Your comma is right there. Up to 117. Comma, 100, comma, 15. Now, your answer for this will always be given as a proportion. But the answer that you would give here would be 57.5%. I can't put a percent in there, or I would. Now, the next problem that I gave you is what proportion of IQs is below 122? Again, what proportion of IQs is below 122? So guys, go second function distribution, same key. Now, this is a little bit trickier, but you guys you're bright people. You're going to catch on. The negative sign, first of all, that's a negative sign, and that's a negative sign. Well, guess what happens if you choose the wrong negative sign? You get an error. So, guys, when you start something with a negative, the negative sign that you're going to use is this one right here. The E, there's a couple of E's. First of all, a lot of people think that where I'm circling right now, right above the sign key, there's a green E. If you want to get this problem wrong and drive yourself insane, choose that one. That's not the right E. The E that we need is right above the comma, and it's actually EE, and it's blue, which means we have to hit the blue key first. Now, even though the notation there is EE on the key, when you hit it, it only gives us one E. So I go E99, and I wanted to find below 122. And the mean and standard deviation we should know are 100, 15. Now again, this is going to be given to us as a proportion, but we were asked to do a proportion, right? But we're going to report proportions to 4 places. So we would report this answer as 0.9288. Now, let's go back to the to Dosery, and I want to point out one more calculator key that I want you to be aware of. And this would be the type of problem that we would run into. I'll tell you what, let me back up on this. There's one more thing I want to cover, and this is percentile ranking. Now guys, I'm sure all of you probably took either the ACT or the SAT, and when you got your score back, I'm sure they gave you a raw score, but they also gave you a percentile ranking. And guys, at the end of the day, all a percentile ranking is, if we have a normal distribution of scores, whatever they may be, and we score at what I call, it's the score of X1. Whatever the percentage of scores is below X1, that's our percentile ranking. So for example, if your score is at the 92nd percentile, that tells you that approximately 92% of the people who took the test on that particular day scored at or below your score. So guys, it should be pretty clear. What are we going to do anytime we want percentile ranking? We're going to use normal CDF, our P key. Since percentile ranking is percent below, we know we're going to have negative E99. The next thing will be the score we're trying to find the percentile ranking of, and the mean and the standard deviation that we're finding the percentile ranking of the score. So in the previous example, we found that the proportion of IQs below 122 was, I forget, 0.9288. So gang, we would say that a score of 122 has a percentile ranking of the 93rd percentile. Guys, percentile rankings are to the nearest percent, the second, the 50th, the 38th, the 92nd. We don't report the 10th of a percent on percentages, just, well, we do on percentages. On percentiles, we don't report the 10th of a percent. All right, gang, one more problem, and let's stick with IQs, which we know again are normally distributed. Mean of 100, standard deviation 15. All right. So what would happen if instead of finding the percentage of scores between two numbers, above a number, below a number, what if we wanted to find the IQ for some reason that has a certain percentage of scores below or above it? And I don't know why, but let's just say for some reason we wanted to investigate the IQ score. We wanted to know the IQ score that has 38% of the distribution below it. Well, guys, the key that works this kind of problem, which finds a score not a percentage, proportion, percentile, and ultimately it's going to roll into probability, but it wants to find a score from a distribution with a given characteristic. We use what's called the inverse norm key. As the inverse norm key, alright, I hope my volume, I think I've had my volume off. Hopefully I didn't. Okay. The inverse norm key uses the mean and the standard deviation second and third. But what goes here is percent below. So what if we wanted to find the score, the IQ score, where only 5% of people had an IQ higher than that? So what we would use the inverse norm because we're trying to find a score from a distribution with a given characteristic. The first thing we have to put in is percent below, but we're given percent above. But knowing that the total percentage has to add up to 100, we know 95% has to be below. Guys, we always have to put this in as a decimal. Put in the mean. Put in the standard deviation. And go to our calculator. Turns out that we go to distribution, come down to number 3. Put in 0.95, comma 100, comma 15. We see the score, an IQ of about 125, places you where only 5% of people got an IQ higher than you, and 95% of people got an IQ lower than you. Because obviously this would also be called the 95th percentile. Now, the problem that I did before, let's go back a screen. What if we wanted to find the IQ that had 38% of the scores below it? Well, those are much easier because we can just go directly to our key. Don't have to subtract from 100 because we want the percent below. And that's what the calculator wants anyway. And hit enter. So I got an IQ of 95 is at the 38th percentile, having 38% of the distribution below it. Guys, that's all there is in this video. Hope to see you Thursday.